Good morning, everybody. Yes, you can hear me. Um, I'd like to apologise this morning, just to say I have a cough. I hope I don't cough, but if I do, it will be awful. So I'll just warn you beforehand. Thank you very much for the invitation to attend. I'm going to talk about some of our recent experience on a wide range of topics, so I won't be covering things in detail. We've had detail over the recent days, but I hope you find it stimulating and see that many of the issues that you face with respect to challenges over sustainability are the same as we face in our experiences. Do I point that way? What's the target? No, I'll stay here. Okay, so the objective of my presentation is to illustrate some of the key challenges faced by sustainable development. And I'm going to address those by thinking about the project cycle for a project. So think more about a port development, a marine terminal development, rather than a strategic plan for looking at how you manage the shoreline. But I'll be looking through the stages of planning, design, environmental assessment, procurement, construction, and then operation of the facility. And in the way I talk about these factors, these topics, I'm going to give a heading for the topic, then I'll say just a few of the key factors related to that topic that I think are important based on our experience, and then I'll make a few comments about some of the lessons that we've learned, hopefully to help illustrate the issues. It won't cover everything. It's not possible to cover everything, but hopefully it will help address some of the issues. So the first thing I'm going to talk about is the location and layout of a particular project. And some of the factors that become relevant when you're thinking about the location and layout of a project are the operability of the facility, uptime at berths, access through channels, and so forth. Obviously, the proximity of the development to sensitive receptors, be they environmental, commercial, fisheries, recreation, and the cost of the whole of the project, be that there's not just the construction, but it'll be the mitigation, compensation, and various other measures. And one of the things that we find based on projects worldwide is that sometimes very early decisions are made about the land that is being acquired by the developer from which the project is going to be located. And there can be a lot of politics involved in that, and very difficult to change decisions over that initial decision. So it's quite difficult sometimes to have the flexibility to modify what you had originally thought was a good idea to be a better idea or a more workable idea, simply because right at the beginning of that process, someone agreed somewhere with a handshake that this is where the project would be. It's not possible to move it 2 kilometres one way because that's somebody else's land, and you already upset them because you made the deal in the first place with one party. So that's quite an important factor for greenfield site development. If it's a development of an existing facility, then it's going to be limited by the existing facility, but you have more flexibility around that. Another important issue for a location is that you are unlikely to know of all the sensitive receptors around that site. Those will become uncovered as you progress your baseline studies and characterization of the site. So you may not know everything about the site that you've selected in the first place. And another important point is that as you begin to think about the layout of your facility, one of the common challenges is how far shall I make my jetty go offshore, or how far shall I bring my dredging inshore to the location of my berths? And quite often, at an early stage, you can have a reasonable idea of the cost of the structure. You may have to make some assumptions about the soils, but you have a reasonable idea of the cost of the structure. But you probably don't have a good understanding of the material you'll have to dredge, so you don't know the costs of that, and you probably don't have a good understanding of future sedimentation in that channel, so you don't have a good understanding of that. So you have to be quite careful in making initial judgments as to precisely how long a jetty is going to be and precisely how long a channel is going to be. And those may be variables as you progress through your studies. Obviously, one of the important things for any of the projects is to make sure that you've optimized the location from a navigability point of view. So navigation simulation studies is always necessary, and understanding the operability of the berth. How much of the time are wave conditions on the berth unacceptable, so you can't unload the vessel or load the vessel? Will you have to build structures to protect the berth to improve that position? And also, we talked about navigable depth yesterday, but knowledge of the wave conditions in the approaches to the berth, so you can understand how much under-keel clearance you need. And in terms of lessons to be learned from this, then obviously you need to define the vessels that are likely to use the facility, both immediately and at some point in the future. You also need to think about vessels that might be using smaller parts of the facility during the construction phases, and recognise that some things won't always be fixed. There may be changes that occur. I'm talking about various factors sequentially, but actually you need to consider these things all at once. So navigation simulation, environmental aspects of the site, sedimentation, structures, you need to be aware of all of these things and iterate as you progress through the development of the design. Structures, I've already said they might be needed to protect the berth. Normally, I think you would be testing the basic layout of structures and what they're likely to achieve using numerical models, and then undertake final testing of structures in physical models. Lessons to be learned really are that smart design can save a lot of money, and you may be able to combine alignments of channels in certain environments where you've got swell waves from a very uniform direction. You may be able to align your navigation channel in such a way that it helps modify the wave conditions, so perhaps you need a shorter breakwater, or possibly even don't need a breakwater at all. But there are various ways you can look at these iterations together. Another important point really to think about is that if you are building a large structure, you need to be aware of what the soil conditions are, and don't discover that the main problem with your structure is not the performance of the structure, but actually how on earth are you going to be able to build this? You've got to make a hole to put a foundation in, and if the hole keeps filling up with mud whilst you're building it, you could be there for a long time before you start building the structure. So smart design is important. And I think it's very important that, we talk about concepts of jetties and dredge channels and offshore locations being more attractive, but you shouldn't avoid, or you shouldn't forget the possibility of bringing the development inshore, putting it close to the shoreline, because land-based construction methods have many less risks than offshore construction methods. So a shore-based harbour or port may actually have some attractions that you discover later in the development of a design. Soil conditions, I haven't got pictures up here that point to the complexities of marine jack-up rigs and so forth for making boreholes and testing soils offshore and things, but obviously you need information about the soil that you're going to be building structures on, and you need information about the soil that you're going to be removing through dredging to underpin your design and to optimize your design. There's always a perception that soil data is high cost, and That's true, so you want to do it correctly and you want to get it in the right place. But by not having soil data at the right stage in your project, it can encounter much greater costs later on. So it's more a matter of cash flow on the project than it being a real issue. You should have this information at the right stage in a project. And what do you get from soils data? Well, it gives you much greater confidence in the methods that you're applying for the development of your structures and the approach you're taking to dredging. If there's a rock present, understanding the properties of that rock, understanding the distribution of that rock is hugely important to optimizing and making a more sustainable development. You don't want to spend lots of time dredging small patches of rock, making lots of noise, using explosives if necessary, if in fact you could have modified the position of your works to avoid that. The other thing with soils is that you need to understand whether any of the material that you are going to be dredging and transporting by pipeline, so possibly to make reclamations, whether that material will change in any way as it's transported through the pipelines. Because you might think that you've got good sand, good granular fill to build a reclamation as part of your development, but in fact, by the time you've pumped this type of material 5 kilometres, half of it's turned into a mud slurry. It's ground down into small particles and you can't achieve what you wanted, and then you've got to do something else, bringing material from somewhere else or doing expensive treatment of the material. Disposal of material arising from dredging. Onshore, offshore, beneficial uses. I started by talking about onshore disposal options. Many of the factors are the same, but key ones I think are, again, proximity to sensitive receptors and how close is your onshore disposal site to where you're doing the dredging. Hopefully it's close. If it's a long way, then it's going to be an expensive process of getting it there. Any onshore disposal, you need to think very carefully about the ability you have to manage the water that's being placed ashore with the material, the transport water, and how can you manage the return of water and fine sediment back into the environment. So you're going to have impacts, plume impacts at the location where the dredging is occurring, and you're going to have them at the location where you're returning the water and fine sediment to the marine environment. You also need to think whether or not you've actually got any material available to you to build the bunds for this onshore disposal. Often the in-situ material may not be suitable. Can you bring material ashore to make these bunds? Can you do it quickly enough to cope with a large project? In terms of lessons learned, then, one of the key ones is to think about the consequences of putting all this salt water onto the site. There are possibilities that your dredging is happening from a river system, so you're then transporting the material with fresh water. But if it's a marine environment and you're pumping salt water ashore, then the consequences for the groundwater and vegetation around the area can be quite important. You also need to think about the long-term management of this onshore disposal. And this relates to disposal, not so much if you're making a reclamation to build something on, but if you're simply allocating land on shore, which you build bunds, place material ashore, and then leave it. Long term, you're going to have to manage the drainage, potential soil erosion off that site, potential problems of dust if you put a lot of fine material there. So you need a plan for how you'll manage the facility for the lifetime of that placement. And then obviously, depending where you are, there can be quite fundamental issues with respect to the pipelines and the network of pipelines you need for the project. There'll be lots of disturbance to activities as pipelines are rotated, turned end to end as the dredging process progresses. Beneficial use of dredge material. Ian mentioned this yesterday. In a sense, if the project can use material, it's going to use it beneficially for purposes of fill, for example. It may need to use some material in clever, innovative ways for mitigating some aspects of the project, maybe helping to restore wetlands somewhere, or creating reefs somewhere for improvement fishery habitat. The other thing that you may be able to do with a project is to provide material to somebody else for their beneficial use projects. You don't want to have to look after that project. You want it to be somebody else's responsibility. But offering material and having a framework for communicating between people who might want material and people who could supply material can allow more material to be used beneficially. Key issues really are what type of material you're going to generate from the dredging. If all of the material is a 50-50 mix of sand and silt or sand and mud, don't assume that 50% of the volume is available as sand for projects. If it all arises as mud and sand, it's quite possible that nothing is going to be very useful. So you need to understand how materials will arise, whether granular material can be segregated, and again, you can influence the layout and the phasing of a project to help facilitate the recovery of useful material. And I come back to the point I made about possibly having a development that's closer to the shore, an onshore, coastal harbour rather than offshore jetty and basin with a breakwater. Because if there are large quantities of material and you need to place material on land to raise the site that you're going to develop, actually having the coastal harbour option, which is deep water close to shore, it facilitates pumping material onto the site, it facilitates importing material if you need to do that. If you've got an offshore basin 10 kilometres offshore, a long jetty, but you need 10 million cubic metres of sand ashore, you're going to be paying a lot of additional money to put the sand ashore. That may not offset other costs, but it would be a useful thing to consider in the overall development. Offshore disposal options, well, we've talked about some of these as well, but again, proximity to sensitive receptors. What's the water depth at the disposal sites? What's the likely capacity of the disposal site? And one of the key issues in different parts of the world is, are people expecting disposal sites to be dispersive or non-dispersive? So in some places, the regulators have a vision that if they're going to allow disposal into the marine environment, it's over a defined area and the material's not really going to move from that location. So then it's a simple matter of, is there volume available? Are the metocean conditions such that material will stay there? In other places, obviously, you know that it's not a bad idea, it's a sustainable thing to feed material back into the system at a disposal site. It's a dispersive site. And then it's a matter of the rate of placement versus the rate of dispersion from the site. But you need to capture those aspects with respect to how discussions are occurring. Some parts of the world, regulators say you cannot dispose material into our state waters. And the only option you have available is onshore disposal. You may be able to convince them that there's beneficial use you could make of material by placing it in the marine environment, but actually offshore disposal isn't a choice. But where it is, and they're interested in only non-dispersive sites, then you need to consider the volumes arising from the capital material and also the volumes arising from a long program of maintenance dredging. And if there's a high siltation problem at the place, then that can be, the maintenance requirements of the sites may be much larger than the capital. The other thing is how are you going to get the material to the disposal sites, and thinking about all of the issues that may arise on those transport corridors. So in lots of parts of the world, concern arises over vessel interaction with mammals and turtles, etc., as they move around in the area of the project. So we've talked about disposal site capacity. The important thing here really is that if you don't know what the future maintenance requirements of a project are, you may have to think about not only defining a disposal site you will use at the beginning, but a whole range of additional sites you may want to use in the future. And if the regulators take the view that those sites, the area of those sites all amounts to the total area of impact that the project is having, you can increase the scale of the project quite considerably. So there's definitely room for discussion with regulators over what is going to happen at these sites, and the value of feeding material into the system in dispersive sites, rather than it always being an issue of a non-dispersive site that's causing there's no change, there's no risk, it's a non-dispersive site, it's just the footprint of the site that is impacted in some way. The other thing, obviously, is that the way in which disposal sites are used can have a bearing on the effects that are generated around the disposal site, whether that's simple sail to the site, open the doors of the hopper, and the material falls out onto the bed relatively quickly. Most of it's gone in 3-5 minutes, maybe a few bits that are falling off over the next few minutes after that, but it's all happened very quickly. Or you can have a situation where a vessel will be moving along a track, maybe for 30 minutes as it releases material, and that's then a more dispersive mixing of material away from the site. You can also have situations where you can actually discharge the material back onto the seabed or close to the seabed using the drag arm of the dredger, which can mean that you reduce the risks of surface plumes and can allow the material perhaps to only be interacting with the nearer bed flow conditions that can occur at a site. So there's lots of ways in which you can manage activities at disposal sites. Moving on from disposal, I'm now talking briefly about sedimentation. Obviously, you could have thought about those two things the alternative way round, and this is the whole point. You have to be thinking about everything almost at the same time. But management of sedimentation, you need measurements to inform you about what's happening, what sort of sedimentation problems are likely to be occurring. If the sedimentation problems are likely to be significant in some way, either at a local position or large scale, large volumes, then you need to start undertaking modelling studies and iterating with more detailed studies to progress that learning curve. If you can understand, based on some early measurements or knowledge of the site, that actually sedimentation at this location is not a huge problem, then you don't need to look at it in as much detail. So you need to get the level of detail you explore things appropriate to the concerns. But when you're thinking about management of sedimentation, you need data and modelling to underpin your knowledge of how the sediment transport processes are occurring. You also need to have in your mind what are the environmental effects that may be associated with this phenomena and management of this phenomena, because there could be some real issues at a particular site that say we can't countenance large maintenance at this location because of proximity of other things. The other thing you need to derive is information to feed your operational expenditure estimates, and I'll come back to this later. In terms of the big lessons learned from various studies we've been involved in, then one of the things that happens when you flag for a particular project that it looks as though there's going to be a high sedimentation issue for that project, it takes a long time for the project team to understand the consequence of that. It's not the same as telling them they need a bigger structure, or that they're going to have to think about the ship they're using. It seems to cause more problems. It takes a long time for everybody to understand what this might mean, really. And that causes delay in the project. So one of the things you want to do early on in any project planning, from a sustainability point of view, is to really try and understand whether siltation is going to be an issue, and if it is, consider whether there are alternative locations where siltation would be less of an issue or more readily managed. And this is a situation that arises for big projects. If you're going to locate a new gas facility somewhere, you've probably got quite a lot of choice as to the locations you choose. Proximity to big rivers, away from rivers, will all help with that. if a project operator recognises that they are going to be taking their project forward with a high sedimentation issue, then they need to also understand the importance to them through the lifetime of their project of understanding and managing that problem. Because it's not a capital problem, it's an operational problem, and it won't go away. CapEx and OpEx estimates are required to inform your design process for a project. You're balancing those two things to understand, to inform decisions you're going to make. They're also a useful thing to have when you start considering evaluating tenders that different contractors put forward for doing the work for you. If you've made a careful estimate as to what you think the cost of building something should be, and a contractor comes with a price which is half or 4 times as much, you've then got some questions to ask. Well, what didn't we understand? What does he know? Is this somebody we want to be working with? Minimising cost is not the same as maximising sustainability, and that's an important message that I think most large developers take on board. It's not an issue for them, they know that, but they do need to have this understanding of cost to take into their balancing of cost versus environmental effects, socio-economic effects. But some of the information that falls out of cost estimates is relevant to the assessment of sustainability. So, fuel oil is easily calculated in terms of the dredging program that's going to be undertaken. You can get a feel for how much oil is going to be used. It's going to be quite a big part of the cost, and you can think about how much CO2 is going to be used to make a particular project or to operate the project. You can calculate how much steel is going to be required for piles, structures, and the dredging pipeline for the project. And you can do the same for rock and cement and concrete and other properties. In the course of all your activities, you're going to have to characterise the site and get some baseline understanding of the site so you can satisfactorily monitor the environmental consequences of your scheme. You need to think about the locations and areas to be monitored, what needs to be monitored, and how long have you got to monitor something to effectively say this represents a baseline. Some of the things we've learnt are that where you have major sedimentation issues, then in all likelihood you'll need to be measuring properties associated with sediment at the site for a couple of years, because you'll need to do it once and then learn the lessons and find out what you really needed to measure and do that the next year. And you'll need to measure during the seasons and things like that. So it takes a time. One of the things that can happen quite often is that at a remote location, there's an expectation that a contractor, once the project is awarded under construction, the contractor will commence with a short period of baseline monitoring. And whilst that's better than nothing, if the contractor turns up in one season of the year, measures baseline, and then 6 months later the natural conditions have changed at the site, then your baseline doesn't represent that condition. Everyone's going to be saying, what's happening? Is this all caused by the project? And it's just nature. So you need to be careful about what baseline monitoring is undertaken by any contractor who's only got a small period of time to do it. Again, environmental constraints in an environmental assessment, you're going to be undertaking all that at the same time as other things. Clearly you need to identify all of the sensitive receptors and activities that might be influenced by the project. Then you've got to assess the risk of your project and variations on your project to all of those receptors, and think about the management measures that may be available for those risks. Big lesson learnt, I suppose, really is this ability to challenge some of the early thoughts on a project. Is this the best location? Are the disposal layouts that are the disposal locations the best locations? I think the other thing you need to think about is, having got a series of risks, hopefully they're minor, but a series of risks associated with the project, are you able to establish a sensible way of being able to manage those risks and adapt the construction activities to minimise those risks if you start to collect evidence through environmental monitoring that suggests you're triggering risks. If you can do that, then you've got a project that you can put forward to the regulators expecting to get approval, and you've understood yourself as to the consequences that may occur to the project, what sort of delays may occur, or additional costs that may occur if you start pushing some of the thresholds of risk. But obviously that doesn't always happen easily, and sometimes the underlying science doesn't necessarily exist to help you with all of those assessments of possible impact. And you have to, it's a balancing act. You can invest in more science for a while, and that will delay the project. In some cases, projects will often, the project vision will be that we will be only applying tried and tested techniques. We don't want to develop any new science on this project, simply to try and minimise the risk of delays. But those are probably lost opportunities to a more sustainable development of projects. An example of a project that was like this was one of the ones we've worked on in Australia, where the vision and all of the discussion with regulators at the start was that the impact of the dredging operation on corals would be measured directly at the locations of corals, and coral health would be used as the measure of impact, not turbidity or amount of light in the water, but actually, is the coral healthy or not? So that progressed through 3 or 4 years of development of the project. And then following a couple of cyclones occurring at the site, as the tenderers were being evaluated for commencing the work, most of the coral was killed. So you couldn't practically measure coral to the accuracy you needed to deliver the study. And they had to then go back and renegotiate with the regulators and then with the tenderers about using turbidity in the water column and light in the water column as a means of saying, are we adversely affecting an environment where corals could exist? When you start thinking about environmental constraints, one of the things that occurs is that you start thinking about the possibility of environmental windows, times of the year when it's less sensitive to, one parameter is less sensitive to another. You need good metocean data and environmental baseline data to help you identify such windows, and you need to understand about extremes for that. So one of the things that can occur is you have to start thinking about whether, if windows are going to be a real issue, should your project be done in one phase only, or do you start your project, do half of it, have a break, cover the costs of demobbing and mobbing again, and then doing the rest of the project? Can you do your project by having more plant available in a single window, or is it better to do it more slowly? So, construction windows are something to think about, but they have a bearing on the consequences. When you're informing your environmental assessment, you need to think about some of the assumptions you've made that underpin that assessment. Those assumptions can be very critical. The first bits of evidence you use to inform early consultation with regulators need to be reviewed carefully, because these things will be some of the hardest things to change later on, unless you've got very good evidence to explain why you changed them. And obviously over-conservative assumptions lead to increased project cost and schedule, but the project may still happen. Non-conservative assumptions can lead you to a rather different situation, that the project is approved, you've agreed various procedures for controlling the project, and then you start building the project and you have to stop. That's obviously a cost, but it's much more an issue with respect to reputational risk to the developer. I think one of the key things there is you need to have a good dialogue with the regulators in order that you can build trust in many ways, so that any changes of this kind are things that you can manage more easily. If you don't have that type of discussion, changing something leads to mistrust from the regulator. And I shall stop at that point. I hope you found that useful.
Thank you for the presentation. Lembro que a gente vai continuar com a mesma dinâmica de ontem, então vamos deixar perguntas e comentários para o debate antes do almoço. A segunda apresentação